Hey students, today we are moving to a new topic, electromeric effect or pi electron shifting. Okay, we are directly moving to the reaction. This is a pi bond system. Okay, a pi bond system is nothing but a organic system is having double bond or a triple bond. So as you know that in a double bond, one bond is sigma bond and one bond is sigma and one bond is pi bond. So which is having pi electrons. When an attacking reagent, let's say an electrophile. Okay, electrophile is electron deficient system. When an attacking reagent or an electrophile approaches to a pi system, pi bond system, or an E theme, these pi electrons will shift towards a nearby carbon atom. Okay. As a result of that, a instantaneous dipole or a polarity created on this pi bond or a compound molecule. So a plus charge on the one carbon and a minus charge on the near adjacent next carbon. So this hydrogen will attack the negatively charged carbon atom, forming a carbocation. Okay, forming a carbocation. So an attacking reagent approaches to a pi system. As a result of that, the pi electrons are transferred to an adjacent carbon atom, and the attacking reagent attached to the necessary charge carried by the carbon atom, forming a carbocation. Similarly, when a nucleophile is having electron-rich species which can able to donate. Let's consider OH minus. When OH minus approaches to a pi system, the pi electrons will shift to nearby carbon atom. As a result of that, a positive and negative charge created on the system, and the OH minus will attack the positively charged carbon atom, forming a carbanion. Okay, forming a carbanion. When this attacking reagent is removed, when we are removing the attacking reagent from the system, this carbocation or carbanion will regain its original electronic condition. When the attacking reagent is removed, the original product is substrate. Original substrate is regain its electronic condition. This effect is known as electromeric effect. It's a temporary effect. It is a temporary effect. Let's note these points. It is a temporary effect in the presence of an attacking reagent on and involve only pi bonds, that is double bond and triple bond, and as a result of the presence of an attacking reagent, the pi electrons are transferred, forming an instantaneous dipole. Okay, instantaneous dipole. When the attacking reagent is removed, it regains its original electronic condition. This effect is known as electromeric effect. And there are two types of electromeric effect, and the classification is known as plus E and minus E, or positive electromeric effect or negative electromeric effect. Let's see here. Here an electrophile is attacking an ethene or a double bond system. Both the pi electrons and the electrophile are moved towards the same carbon. If this is the first carbon, if this is the second carbon, the pi electrons are moved to the second carbon, and the electrophile is attacked the same second carbon. This kind of effect is known as plus E effect. Okay, the pi electrons and the attacking reagent attached to the same carbon or the same site, which is known as plus E effect. The presence of electrophile create these kind of plus E effects. Okay, and when a nucleophile is generally denoted as Nu minus. Okay, when a nucleophile, here it is an OH minus. When an OH minus approaches to a double bond system, the pi electrons are moving to the second carbon, but the attacking reagent attached opposite to that movement of pi electrons. That is, the attacking reagent, the nucleophile attached to the first carbon, not to the pi electron transferred carbon. Okay, I hope you understand. The nucleophile attacked opposite to the carbon to where the pi electron is transferred. Such kind of transaction or effect is known as minus E effect or negative electromeric effect. Okay. Plus E effect and minus E effect. Minus E effect can be illustrated simply like this. When an alkene, a double bond system, is attacked by an electrophile forming a carbocation. This is called plus E effect. Okay. When a nucleophile attack to a double bond system, an alkene, which direct to the formation of a carbanion. Okay. That is, the pi electron and the attacking group attached to the same site. That is called plus E effect. And the minus E effect, the pi electrons and the attacking group are at different site. Okay. Simply it is, we can explain in this manner. So, the electromeric effect can be used for the formation of carbocation and carbanion, also used to determine the product of an organic chemical reaction. Let's move on to the second part. There are two types of electromeric effect on two, symmetric and unsymmetric. In symmetric compounds, let's take the example of ethyl. This is a double bond system, and alkyne, ethine, a triple bond system. In both cases, when an electrophile approaches, the electrophile can attack either of the carbon. Whether to attack the first or whether to attack the second, the final product will be the same, in symmetric in nature. And similarly for the triple bond case also, it can attack to the first or second carbon, creating the same product. But consider a ketone or an aldehyde. Here an oxygen is there. Oxygen is having high electronegative than carbon. Hence, as a result, when an electrophile approaches, the pi electrons will shift towards the electronegative oxygen atom, and the electrophile attack the oxygen, not the carbon. This kind of unsymmetric electromeric effects. Let's consider the second example. Here, one alkyl group is attached to a double bond system. Okay. So, we can expect two products. Whether the pi electrons can transfer to the middle carbon or to the terminal carbon. But the transfer of pi electron depends on the stability of carbocation formed as an intermediate. So, the pi electron will transfer only to the terminal carbon, forming a secondary carbocation. Secondary carbocation is high stable than primary carbocation. So, the resultant will be CH3, CH2 minus, and here the plus. And the electrophile will attack to the terminal carbanion or carbon, forming a secondary carbocation. So this product is more stable. So we can use electromeric effect for these kind of applications. Okay, thank you very much.